and welcome to another WJEC A level physics question. This time it's a Unit 3 question nowadays, but was a Unit 4 back in the day. And this is from the Unit 4 June 2013, and it was question 4 on that paper. And what we've got is a rod attached vertically to a horizontal turntable at a point P, which is 0.08 meters from the center of the turntable Q. And first thing we're told is that the turntable rotates at 45 rotations per minute, and we've got to show that its angular speed omega is 4.71 radians per second. So what we've got to remember is that the angular speed omega measured in radians per second is literally the number of radians swept out per second as this turntable rotates. So what we've got is basically at the moment that the frequency is 45 revolutions per minute. And if we divide that by 60, we're going to get the number of revolutions per second, or the number of hertz. So that's going to be 0.75 hertz. And then we can use omega is equal to 2 pi f. Now that's not given in the data book, but it should be something that's fairly obvious, because the number of radians rotated through in every revolution is 2 pi. So if we multiply 2 pi by the number of revolutions per second, we get the number of radians per second. And we're asked to show that it's 4.71. If I just give an extra figure from the calculator, it's 4.712 radians per second. Next, we're asked to calculate the speed of the rod. So this is a very simple question where we can use the formula from the data book that the speed of the rod is omega times r. Omega is the 4.71, and r here is 0.08 meters. Put that into the calculator and we'll see what we get. 0.377. I'll stick to 3 significant figures here. And don't forget the unit of meters per second. To calculate the acceleration of the rod, again this is a straightforward question. We have various formulas for acceleration. We have v squared divided by r, or omega squared r. Personally, because I've got v as the last answer on the calculator, I'm just going to use the v squared over r version. But I've already stored omega in the calculator's memory, so I could have used that as well. And that gives us 1.78 meters per second squared. Next, we've got to state the direction of the acceleration of the rod. So this is pure learning that the acceleration is always towards the centre of the circle. That's why they call it a centripetal acceleration. The question continues by moving into a little bit of simple harmonic motion. So what we've got is light is now shone onto that turntable from the side, and the shadow of P moves up and down on this screen that we got on the right hand side there. And the displacement x in meters of the centre of the shadow from the centre of the oscillation is given by x equals a sine omega t. That tells us that we actually start timing when P is basically horizontally level with Q, in other words when x is 0. And we're also told that x is equal to minus omega squared times a sine omega t. That comes from the definition of SHM, where the acceleration is directly proportional to the displacement, and a sine omega t is the displacement, and omega squared is the constant of proportionality. And the minus sign reminds us that the acceleration and the displacement are always in opposite directions. So what we've got here is we've got to write down the value of the amplitude. Well, the amplitude is the maximum displacement of this shadow, and that will occur when P is basically all the way up here vertically on the diagram. So it should be obvious that that's 0.08 meters. Next, we have to calculate the value of the period of the oscillation. Well, there's a formula in the data book that T is 2 pi over omega, so we can just simply use that. And this again is why it's useful to have stored the number in a memory earlier. That gives us exactly 1.3 recurring, so let's call it 1.33 seconds. I should show the workings there for completeness, so 2 pi over 4.71. Then we've got to calculate the acceleration of the shadow at time t equals 0 seconds. So we can just plug in values here. Mustn't forget the minus sign. Omega was 4.71. Amplitude is 0.08. Sine of 4.71 times 0.2. And a very important thing here to remember is that your calculator must be in radians mode. A very common mistake is that people leave their calculator in degrees mode and you will not get the correct answer out of this. So always make sure you're in radians mode for this. So let's plug in the figures and see what we get. Almost done. And we get minus 1.44 meters per second squared. And the minus sign is important to get full marks in the answer. Next we're asked to state what's meant by simple harmonic motion, in other words give its definition. So let's write this down. Oh, let me remember to put the pen back on. An object is executing SHM. If its acceleration is directly proportional to its displacement from a fixed point, usually known as an equilibrium position, and is always directed towards that point. Now, alternatively, you can define it as saying that the acceleration is directly proportional to the displacement and always in the opposite direction to the displacement. But this is the version that WJEC give in their data in their definitions booklet. For part 5, we've got to clearly show that the expressions for x and a agree with the definition of SHM. Well, the equation for x was a sine omega t, and the equation for the acceleration was minus omega squared a sine omega t. So looking at the right hand side here, a sine omega t is x. So what we've got here is basically that the acceleration is directly proportional to omega squared is that constant proportionality x, and in the opposite direction. So that's all we're really looking for, is the idea that a is minus omega squared x. Next we've got a second rod now attached at position R, which is 0.06 meters from the center, and there's a 90-degree angle here. And what we're going to do is fill in the values for the equation for the displacement of R. Well, in front of the sign we have the amplitude, which here is going to be 0.06 meters. It's rotating at the same rate, so it's got the same omega of 4.71. But R is trailing behind P by an angle of 90 degrees, and 90 degrees in radians is pi by 2. So we've got a minus pi by 2 there. So thank you very much for listening. Please remember to like and subscribe, and add any comments you like below the video. Goodbye.